So today we have a different question, and this question is requiring us to come over here and determine the perimeter as well as to prove that whatever minimum value that we find is actually a minimum value of the perimeter. So this is what we're going to do. Okay, just grab the calculator over there. So let's start. We're going to identify a couple of things. So first of all, I want us to first understand a couple of things, and that is, what does area mean? What does perimeter? What does perimeter mean? And what does volume mean? Now, obviously, we're not dealing with volume here today, but let's understand these. So the area is basically the flat um, space between the lines, right? So between the lines. So the area is all of this, just this, finding out whatever amount of space is between all of these lines that you're seeing here. And then the perimeter is how long those lines are. So if you were to find a ruler and if you were to measure the length of each and every single type of line here, that is going to be you trying to find the perimeter. And the volume is basically the 3D space. So an example of things that have volume, this particular juice bottle here has volume. So the volume would be occupied by the fluid that you're seeing within here. And I can assure you this is apple juice. I'm trying to teach. That is a terrible joke. But yeah, first of all, understand those concepts and we can move on to something else. Okay, so now trying to prove. There are multiple concepts that you're going to be understanding here, and in terms of also trying to identify certain things that we're also going to be talking about in relation to the area of a semicircle and how all of that actually gets to work, and the perimeter of a semicircle as well, and how actually that gets to work. So they say find the area. Let's say for area, we're using A, and for perimeter, we're denoting it as P. Okay, so for you to find the area will be area of an entire circle is what? The area of an entire circle is okay, let me write it over here. It's pi r squared, right? That's the area of an entire circle. So if the area of an entire circle is pi r squared, if you cut this by half, that means that the area of your semicircle has to be half of that original area. The area of a rectangle is going to be L multiplied by B, so length multiplied by breadth. In relation to this, you can just determine which one is length and which one is breadth. Let's try and choose this one as length because it looks a bit longer, and let's make this one breadth. So the area of this entire surface is going to be considering the area of both or all these three particular shapes that you're seeing over here. So that's going to be involving 1 over 2 pi r squared plus 1 over 2 pi r squared. Why? Because we have two semicircles plus length times breadth. Now we can just add these two, but let me write it down. So x squared y x squared, because x is the radius, plus 1 over 2 pi x squared plus what? xl and yb, so x multiplied by y. All of this can be written down as pi x squared plus xy. Don't do any simplification, you don't need to do that, just rest it over here. So that's the expression that you're sitting on right now. It gives you these two terms, right? So now you want to find out a way to kind of like get it to the point where you get to determine the rest of the things. So perimeter is where everything is at. So remember, perimeter is going to be considering the lines that you're seeing, okay? So here's a very fascinating thing that you're going to be getting to see over here. So in terms of a semicircle, right? So let's deal with a circle. The perimeter of a circle is denoted by 2 pi r. That's the perimeter of a circle. The perimeter of a semicircle depends on whether or not if that semicircle is open or if that semicircle is closed. Okay? So the perimeter of a semicircle, such as this one, right, is actually pi r. But, and let me tell you why it's pi r. If 2 pi r is going to be considering all of these lines, right? Let's say starting from this point, let's say that this is the starting point. If this is your starting point, and 2 pi r is going to be the length of this line from here to here, that means that if I cut this line, drawing this line from the starting point of 1, and I end over here, that means that I've only drawn half of the line. Henceforth, the entire perimeter is going to be what? It's going to be half of what I had initially, because I have not completed the journey. Henceforth, it makes sense why your perimeter would have to be pi r. But for this one, I add another line and the segment wherein there is no space. So if I do that, that means that my perimeter now is going to be pi r plus, remember, if this is a semicircle, that means that over here at the center you would be finding a radius and a radius on that side, henceforth forming the complete diameter. So henceforth your perimeter for a semicircle that is not open would be pi r plus 2r. Okay, I hope you understand that. All right, so now let's solve the mystery. So we have in this section, you're going to be having, so let's start with this circle over here. So that's going to be pi r, remember, from here to here. So let's determine that. And then plus what? Plus r, 1r. Why is it 1r? Because the other one is not present. So plus 1r. If you do that for the other circle as well, you can repeat the very same process. You're going to say pi r plus r, because you're doing this, and then you're doing this. So only these two sides are left. But these two sides are just going to be what? 2y, because the x section of or the length of the rectangle is actually not present. Okay, so just going to be 2y. The dotted lines are there to represent that it's not present. I hope that's very clear. So you move forward, try to simplify things. You're going to be having yourself 2 pi r plus 2r plus 2y. Okay, so what's 2 pi r? 2 pi r is basically 2 pi x plus what? Plus 2x plus 2y. Now I want you to remember the area that we were given was 20 centimeters. I forgot to write it here. So 20 centimeters. So what you want to do in terms of simplification is that you would want to have the only thing, or the only term or variable that you do not find them asking you to prove in the given formula. So in the given formula, you have 2x plus 40 over x. There's no y there. So what you want to do is that you want to get rid of y. How do you get rid of something? If it's in an equation form with multiple variables, you make it subject to the formula. So that's going to be y is equals to what? Y, okay, let's say xy is equals to 20 minus pi x squared. Divide both sides by x. That's going to give you y is equals to 20 over x minus pi x squared divided by x. Don't cancel, leave it as it is. It's okay, we'll do it elsewhere. Then come and say 1, and then this is your equation number 2, so you can come and say sub 1 into 2, and that's going to be giving you perimeter is equals to 2 pi x plus 2x plus 2 into what? Into 20 over x minus pi x squared divided by x, right? And then after that, what can you do? You're just going to come and say p is equals to 2 pi x plus 2x plus 40 of x minus 2 pi x squared divided by x. Okay, now since they want you to be able to cancel out this and this x off of this x squared, for you to be able to subtract this out, that you can only have 2x, that's definitely what you're going to do. You're going to come and say 2 pi x plus 2x plus 40 divided by x minus 2 pi x. Okay, this is, yeah, but it's fine. So this and this is going to cancel. Don't make a mess like this on your question paper, okay? And then you're going to be left with 2x plus 40 over x. Right, so write it as it is. I don't know, you can say therefore, and then you'll get your marks. Now let's move on to the other question. Okay, so this is it. I would advise that you take a screenshot or write down the question. I'm going to place the question on the screen so that you can take a screenshot or you can write it by yourself. But the main thing that we're going to be focusing on is this primary thing right here, proving its minimum value, because that's a term that may be very confusing. It's one thing that I found confusing in my prior years, but we're going to try and explain it in great detail over here. So, question B, do you want me to find the minimum value of this particular expression and henceforth determine that this is actually the minimum value? So first things first, what do you do? Minimum values, maximum values, where do you find them? Minimum values and maximum values just denote that you're going to be having a curve at some point in terms of your expression. Because if you don't have a curve, and your expression is representative of a graph that is continuous, then you can't have a maximum or a minimum value, because your continuous values denote that you're going to be having the minimum value being your being negative infinity and the maximum value being positive infinity. So that's not what we're dealing with here, and we're gonna try and make it work. Okay, so there we go. The camera just focused right back in. So minimum value, maximum value, it denotes this, right? I don't, when you hear the word minimum and maximum value, what I don't want you to think about is the shape. I don't want you to think about, okay, by minimum parameter and maximum parameter, are they talking about, increasing the shape, decreasing the size of the shape? I don't want you to think about that. What I want you to think about is the fact that this expression can be represented in terms of graph form, and the minimum and the maximum values are found in curves, right? That's what I want you to think about. I want you to think about curves and graphs and all that stuff. So in terms of curves and graphs, that's where you get the opportunity to get to work with derivatives. Um, and that's what we're going to be doing over here. So you get to find the minimum or the maximum value based on the derivative, because the derivative gets to tell you the gradient or the changing concavity, um, or the changing slope at different points of the initial graph. So this is going to be the expression of your initial graph. When you find this derivative, you're going to be finding the gradient of the different x values or the different points of the initial graph. So we're going to do this. You get your 2 over there, and then you're going to be getting it's minus 40x to the power minus 2. Now, let me tell you what I don't advise and what I do advise. When you have an expression such as this, what I don't advise is you jumping straight into doing this. Okay, this is correct, but I don't want you to jump straight into this. What I want you to do is that I want you to come and say p is equals to 2x plus 40 over x, write it out like that, and then simplify it. Don't write it with the variable being an inverse. Come and say 2 of x plus 40 multiplying s to the power minus 1, because then it makes it very simple for you to come into this direction, come and say minus this, multiply this by minus 1. So it makes the rest of the operation very simple. Just take that into consideration. All right, now we're continuing. So what are we finding? First derivative gives you 2 minus 40 x minus 2. So remember, if we're trying to find the minimum or maximum point of a curve, right, the gradient at the minimum or the maximum point is 0. And if the derivative of the initial expression or the initial equation is an equation of gradient, or is denoting the gradient at the different points, that means that the result of that first derivative or of that derivative of the initial equation needs to be giving you information relative to the gradient. And in terms of the turning point, looking at where the turning point is located, the turning point must have a gradient of 0, because when you come and place the equation of that derivative at that particular point, the turning point, at the particular turning point, the graph comes and lays level. And being level with the ground or being level with the x-axis gives you a gradient of 0. So what would you want to do? You want to come and place 0 in this region. Come and say 2 minus 40 x to the power minus 2. Why do you place 0 here? Because the y value is the one that's going to be giving you the gradient of the initial equation. So the result of the derivative is going to be the an answer denoting or telling you the gradient at that particular x value for the initial equation. I'm repeating this because this is basic uh, differential equation concepts, different basic optimization concepts that you need to know, basic calculus concepts that you need to know, even in terms of cubic functions and other types of functions as well, as long as you're going to be deriving. So that's very important information right there. Okay, so we did that. Now we're moving forward. What do we see? You want to take the positive. Okay, we can come and do it like this. Although you didn't have to do that, you could have just taken this one on the other side. Then you can divide both sides by -40. That gives you 1 over 20 is equals to x to the power minus 2. Henceforth, your answer is going to be 20. Once you take out the inverse, then you'll come and do this, say plus or minus. Why do you say plus or minus? Because if it's squared, it can have two values. So that will be giving you, I think it's minus 2 root 5, or x is equals to 2 root 5. There we go. So since we're dealing with the x values that are in relation to distance, right? This is actual distance of a living object. You can't have distance being negative, so henceforth your answer can't be a negative value. So you should actually come and say therefore x is equals to 2 root 5. Um, if you want to make it out, or like make it very apparent of what exactly you're talking about, you can write a statement on this side saying x is distance, or x is supposed to be an element of a real number, all that stuff, whatever it is that you want to say. But this is not necessary. Waste of time. You don't get marks for this. This is what you get marks for. So this is your x value, right? And you want to come and take this x value because you're believing that this is the x value for the minimum perimeter. So you're going to come and take that x value, come and say p, and then you come and substitute it into that region, plus 40 over, and then your answer, let's see what your answer would be, 2 multiplying that, 40, that. So your perimeter is going to be 8 root 5 centimeters. Remember, you are given units. Use them. Don't forget to use those units. Otherwise, you won't get a mark. So that's your minimum perimeter, right? However, if you remember, the second part of this was that you should prove that this is a minimum value. So how do you prove that this is minimum value? We're going to get into that. So let's go to determine whether or not if it's valid. Minus 2, and then you write your second derivative, okay? That one becomes 0, then you have yourself 80 x to the power minus 3. So what do you want to do? You want to come and determine the concavity of the graph at that particular point. Okay, you want to come and determine that. You want to determine if is it concave up or concave downwards at that particular point. That's what the second derivative of your initial equation should be telling you, right? And remember, if it's concave up, then you have a minimum value. If it's concave down, you have a maximum value. And the concave up means that the result of your second derivative has got to be positive, and for a concave down, the result of your second derivative has to be negative. Okay, so let's see, what are we getting there? Because this I just want to affirm this. Okay, your second derivative tells you the concavity, your first derivative tells you the gradient of the particular point on your initial equation. So remember that the first derivative is all about gradient. Is it positive or negative? The second derivative tells you about concavity. Are we going up like this, or are we going down like that? Or are we smiling, or are we frowning? Those are the better terms. So you found your second derivative. Now what you want to do is that you want to come and place whatever it is that you found in relation to the x value for that particular point. The x value that you used to determine that this was the maximum value of the perimeter was x is equals to 2 to the power of 5, rather x root 5, right? That's what you were finding, and that's where you found that the perimeter at this particular x value was 8 root 5. There's a lot of redundancy here, but I'm trying to emphasize a certain number of things. So you come and take this particular value, you come and place it over there, you come and say 80 5 to the power minus 3, and you're going to come and say 80 multiplying 2 root 5, all of that to the power minus 3, and your answer is 0.894. So you come and say, therefore, since your derivative is actually greater than 0, therefore your graph is concave up, therefore the perimeter is minimal, right? I hope you understand that. If you have any questions, ask in the comment section. If you like the video, please do like and subscribe. It's very much important. Helps us a lot.